An ancient bronze gear holds secrets we still cannot fully unlock. This journey explores 30 scientific instruments whose exact purposes remain heavily debated, offering you a new perspective on the brilliant and mysterious minds of our ancestors. We will see a Roman object that appears in dozens yet defies explanation, and a Chinese device said to predict earthquakes with mythical creatures. By the end, you will understand how these puzzles redefine the very timeline of human innovation. Why did entire systems of knowledge vanish without a trace? And what can their silent artifacts teach us about our own place in history? What forgotten invention do you think is waiting to be understood once more? That corroded lump of bronze, pulled from the Aegean Sea, would eventually force a complete rewrite of our understanding of ancient engineering. Known as the Antikythera Mechanism, this object is not merely a miniature cosmos captured in metal, a philosophical idea given physical form. For decades after its discovery, its true complexity remained hidden beneath layers of calcified sea deposits. It was only when researchers began to peer inside using advanced imaging techniques that the staggering truth emerged. Here was a device with over 30 interlocking bronze gears, arranged in a precise clockwork system of astonishing intricacy. It was a machine for modeling the heavens. Its primary function, scholars largely agree, was to act as a mechanical calendar and planetarium. By turning a hand crank on its side, an ancient user could advance the device through time, watching as tiny pointers tracked the sun and moon across the zodiac, predicted lunar phases, and even forecast eclipses with remarkable accuracy. It was a portable, user-friendly universe, a tool for both education and perhaps religious or civic planning. But this consensus is only the surface of a much deeper mystery. The true debates begin when we ask what else this cosmic computer was meant to do. Some researchers point to inscriptions on the device's fragments that mention cycles of 4 years. This has led to a compelling theory that one of its dials was specifically calibrated to track the 4-year cycle of the ancient Panhellenic Games, including the Olympic Games. Imagine a philosopher or a wealthy patron not only contemplating the movements of Venus, but also knowing when the next great athletic festival would be held. It connects the celestial with the civic, the cosmic with the cultural. An even more tantalizing puzzle involves the planets. The 5 wandering stars known to the Greeks, Mercury, Venus, Mars, Jupiter, and Saturn, followed paths that were far more complex to calculate than the Sun and Moon. While the surviving gears clearly model the lunar and solar cycles, evidence for planetary gears is fragmentary and hotly contested. Did the original, complete mechanism include a breathtakingly complex subsystem to replicate the irregular motions of all 5 planets? If so, it represents a leap of mechanical genius that would not be seen again for over 1,000 years. This single device implies a lost tradition of Greek gearwork, a school of thought and craftsmanship that vanished into the historical shadows, leaving only this one salvaged whisper behind. It stands as our first and most profound lesson, a reminder that the past often held knowledge we are still struggling to fully recover. That cosmic computer from Greece feels almost alien in its sophistication, but the next object grounds us in the tangible, everyday world of an empire. From the damp soil of Britain to the sun-baked fields of Hungary, a peculiar artifact keeps turning up. It is a small, hollow object cast from bronze, no larger than a modern baseball. Its surface is divided into 12 flat pentagonal faces, each pierced by a circular hole of a different diameter. At each of its 20 corners sits a small, solid knob. This is the Roman Dodecahedron, and it is a mystery born not from rarity, but from overwhelming commonness. Over 100 of these geometric puzzles have been unearthed across the vast expanse of the former Roman Empire, from its northernmost frontiers to its heartland. They are not hidden in royal tombs or temple vaults, but found in ordinary places, suggesting they were tools of daily life, owned by soldiers, merchants, or craftsmen. Yet here lies the central contradiction, a silence that echoes louder than any discovery. In all the meticulous records, the engineering manuals, the letters, and the literature left behind by the meticulous Romans, there is not a single written word, not one drawing or description that mentions these objects. It is as if an entire society decided to use a common tool and collectively agreed never to speak of it. This absence has opened a floodgate of speculation, each theory attempting to solve a riddle the Romans themselves saw no need to explain. One of the most persistent ideas casts them in a practical light, as simple gauges for standardizing the diameter of metal or wooden rods, perhaps for military applications like spear shafts or for construction. The different-sized holes could have allowed a craftsman to quickly check if a component met a specific standard. Yet this theory stumbles on a simple question: why adorn a simple measuring tool with such ornate, carefully crafted knobs? Others have proposed more domestic rolls, suggesting they were elegant candlestick holders with a wax taper inserted into a hole, or even frames for knitting gloves, a theory that, while charming, lacks supporting evidence from textile finds. The most captivating theories reach for the stars. Some researchers note that the different hole sizes could correspond to specific angles, turning the dodecahedron into a rudimentary surveying instrument for calculating distances or land plots. Others, inspired by the Antikythera Mechanism, wonder if these objects held an astronomical purpose, a handheld device for tracking celestial cycles or determining the optimal dates for planting crops based on the sun's angle. Each idea feels plausible in isolation, yet none fully satisfies the puzzle of their universal presence and total textual silence. Perhaps the true function was so obvious to a Roman citizen that it never warranted documentation, a piece of common knowledge that evaporated when the empire's connective culture faded. This transforms the dodecahedron from a mere artifact into a profound lesson. It reminds us that history is not just written in grand monuments and epic battles, but in the quiet, unrecorded routines of daily life. The most enduring mysteries may not be about lost advanced technology, but about the simple, forgotten gestures of a civilization, the knowledge held in the hands of its people, now silent and waiting in the earth. The silence surrounding the Roman dodecahedron is a mystery of absence, but our next object presents the opposite problem, a cacophony of modern interpretation projected onto a simple clay pot. In the 1930s, during excavations near Baghdad, workers uncovered a small, unassuming artifact that would ignite one of the most persistent debates in the history of archaeology. It was a clay jar roughly the size of a man's fist, dating from the Parthian period around 2,000 years ago. Sealed with an asphalt stopper, it contained a rolled copper sheet cylinder, and within that cylinder, an iron rod. To the archaeologists who first catalogued it, it was an interesting but not extraordinary find, possibly a storage container for precious documents. But decades later, a new theory would recast this humble jar in a dazzling, anachronistic light. An Austrian researcher proposed that the arrangement of dissimilar metals, separated by an electrolyte, was no accident. If the jar had been filled with an acidic liquid, like vinegar or fermented grape juice, the chemical reaction between the iron and copper could have generated a small electrical potential, a weak but measurable electric current. In essence, he argued, this was an ancient battery, a primitive galvanic cell predating the official discovery of electricity by over a millennium. The implications were staggering. What could such a current have been used for? The most popular theory suggests electroplating, the process of using electricity to coat a base metal with a thin layer of a precious one, like gold. Experiments with modern replicas of the jar, filled with a suitable electrolyte, do indeed produce a faint voltage, enough to plate a small object with gold if left for a considerable time. This idea paints a picture of ancient artisans using a form of technology we thought was centuries away, achieving decorative effects through quiet chemical magic. Yet skepticism is a vital tool in archaeology, and many scholars urge profound caution. They point out that not a single electroplated object from the Parthian era has ever been conclusively identified. Furthermore, no wires, connectors, or other associated apparatus have been found alongside any of the several similar jars discovered. The alternative explanation is far more mundane and perhaps more likely within its original context. The asphalt seal was excellent for preserving contents from moisture, and the inner copper cylinder would have been a perfect protective case for a precious scroll, perhaps a religious text or an important document, with the iron rod acting as a simple stiffener or core. This debate is about more than just the function of a single jar. It represents a fundamental tension in how we view the past. Are we seeing a spark of proto-scientific genius, a technology lost and rediscovered through the lens of our own electrified world? Or are we imposing a modern narrative on an object that made perfect, practical sense within its own time and culture, a sense we have simply forgotten? The Baghdad Battery, whether a vessel for sacred words or for silent electrical charge, forces us to confront our own assumptions. It asks us to consider whether the most profound leaps in ancient innovation might look, to our eyes, deceptively simple, or if our desire to find ourselves in the past sometimes leads us to see sparks where there were only carefully preserved words. While the Baghdad Battery debate centers on interpreting a single function, another discovery presents a far more complex language written in gold and bronze. The Nebra Sky Disk, found not by archaeologists but by looters with metal detectors in a German forest, is a breathtaking artifact that violently rewrote our understanding of Northern European prehistory. Fashioned from bronze and inlaid with gold symbols, this disk, about the size of a large dinner plate, dates to around 1,600 years before the Common Era. It is, astonishingly, the oldest known concrete depiction of the cosmos anywhere in the world. Its imagery is both beautiful and unmistakable: a crescent moon, a full circle that may be either a full moon or the sun, and a smattering of stars, including a distinctive cluster of 7. This cluster is almost universally agreed to represent the Pleiades, a star group that has served as a seasonal marker for agricultural societies across the globe. 2 golden arcs along the disk's edges add further intrigue, and later additions include a third arc at the bottom interpreted as a solar boat, a mythological vessel thought to carry the sun across the sky. There is no debate that this object is profoundly astronomical, but consensus shatters the moment we ask what it was for. Was it a practical farmer's almanac cast in metal? By observing the position of the Pleiades relative to the moon, a Bronze Age community could have determined the correct times for sowing and harvest, synchronizing their labor with the celestial clock. The 2 opposing arcs are precisely the right width to represent the angle between the sunrise points at the summer and winter solstices, as seen from that specific hilltop in Germany. This suggests the disk could have been a sophisticated handheld instrument, used in conjunction with distant landmarks on the horizon to calibrate the solar year. Yet its exquisite craftsmanship and use of precious materials argue against it being a simple tool. It was almost certainly an object of immense power and ritual significance, perhaps wielded by a spiritual leader or a chieftain who held the secret knowledge of the seasons. The disk then becomes more than a calendar. It is a symbol of authority, a physical representation of the covenant between the people, their leaders, and the heavens themselves. The later addition of the solar boat arc reinforces this, moving its purpose from pure observation into the realm of mythology and cosmic storytelling. The Nebra Sky Disk offers no easy answers because it likely served all these purposes at once. It is a calculator, a sacred icon, and a political emblem fused into one. It shows us a Bronze Age mind that did not separate science from spirituality or practical timekeeping from divine order. To hold that disk was to hold a model of the universe and one's place within its cycles, a profound attempt to harmonize human life with the vast, predictable, yet mysterious motions of the sky above. The cosmos depicted on the Nebra Sky Disk was a fixed, symbolic map, but the human desire was always to measure its moving parts with greater precision. This pursuit led to an instrument so elegant and enduring that its refined Islamic and medieval European forms are celebrated as masterpieces of science and art, the astrolabe. Yet its origins, like so much of classical knowledge, are rooted in the earlier, shadowy world of ancient Greece, and those beginnings are far less clear. While the sophisticated brass astrolabes of later centuries are well documented, their Greek precursors exist mostly in fragments of text and tantalizing hints, leaving us to wonder what the original prototype truly was and what it was built to do. The great astronomer Hipparchus, working in the 2nd century before the Common Era, is often credited with its invention, or at least with a foundational discovery that made it possible. His crucial contribution was the mathematical theory of stereographic projection, a method of mapping the three-dimensional dome of the sky onto a two-dimensional flat plate. This is the brilliant conceptual leap at the heart of every astrolabe, transforming the complex sphere of the heavens into a manageable, rotating chart. But the physical device Hipparchus might have held remains a ghost. Was it a simple observational tool, a bronze circle with a sighting arm used to measure the altitude of stars above the horizon? Or had he already combined this with an engraved plate, a planisphere that allowed for calculations? Some scholars argue these early versions were purely practical, tools for sailors to find their latitude or for architects to align buildings. Others see in the writings of later Greek thinkers like Ptolemy suggestions of a more ambitious purpose, a device not just for observing but for calculating. It could solve problems of time, determining the hour from the sun's position, or even model the movements of planets for the complex charts of astrology, which in the ancient world was inseparable from mathematical astronomy. The deepest debate, however, is whether it was also a philosopher's teaching aid, a tangible model for demonstrating celestial mechanics to students in an age before precise clocks or printed star maps. This evolution from a possible Greek teaching tool or observational aid to the multifaceted Islamic mathematician's jewel is a powerful story of cultural transmission. As knowledge passed through Byzantine, Persian, and Arabic scholars, the astrolabe was not merely preserved, it was profoundly enhanced. They added intricate prayer time calculators, engraved it with exquisite artistry, and expanded its functions to solve hundreds of problems related to time, location, and the stars. The original, simpler Greek form was absorbed and transformed, its initial purpose becoming a subject for historical detective work. This journey highlights a vital truth about ancient instruments. Their meaning was not set in stone or in bronze. It was shaped by the needs, the beliefs, and the brilliant ingenuity of every culture that held them, each adding a new layer of understanding to a tool designed to comprehend the sky. The sky was a map to be read, but the earth itself held secrets far more violent and unpredictable. In the year 132 of the Common Era, during China's Han Dynasty, the brilliant court astronomer and engineer Zhang Heng presented the emperor with a device that seemed to defy the very nature of perception. It was a large, ornate bronze vessel nearly 6 feet in diameter, its surface adorned with 8 dragon heads, each gazing outward in a cardinal or intercardinal direction. Beneath each dragon's open mouth crouched a bronze toad, its own mouth agape in anticipation. The beauty of the object was matched only by the audacity of its claimed function. According to historical records, this vessel could detect the direction of an earthquake occurring hundreds of miles away, a tremor too faint for any human in the capital to feel. When a distant quake struck, the mechanism inside would be triggered. A dragon facing the epicenter would release a heavy bronze ball from its jaws, and the ball would clatter into the waiting mouth of the toad below with a resonant clang, announcing both the event and its bearing. The concept is breathtaking, a mechanical sentinel for planetary unrest, but the detailed mechanics of Zhang Heng's seismoscope died with him. Not a single component of the internal works has ever been found, leaving only the poetic description of its operation and a void filled with centuries of speculation and engineering debate. The central mystery is what clever arrangement of weights and levers lay inside that bronze jar. The most prominent theory suggests an ingenious use of an inverted pendulum. Imagine a heavy mass suspended from the top of the vessel, delicately balanced. When seismic waves arrived from a specific direction, they would impart a slight motion to the vessel's base. The inertia of the suspended mass would cause it to lag behind this motion, tilting relative to the jar. This tilt could then trigger a system of connecting levers that would release the ball from only the dragon aligned with the quake's origin. It is a beautifully simple and mechanically plausible solution. Yet other scholars propose even more complex internal systems, perhaps involving a central column resting on a sensitive pivot or a chamber of liquid mercury that would slosh in a specific direction to activate the release. The debate is not merely academic, it cuts to the heart of the device's true nature. Was this a genuinely sensitive scientific instrument, a practical early warning system for a vast empire prone to seismic disasters? Or was it something more profound and symbolic, a magnificent demonstration of imperial power and cosmic philosophy? Modern attempts to reconstruct the device based on the pendulum principle have shown some success in indicating direction, but questions remain about its purported sensitivity to such distant events. This leads some historians to view it as a brilliant piece of statecraft. In the Han Dynasty worldview, earthquakes were not random geologic events, but potent omens, signs of heavenly displeasure or imbalance in the emperor's mandate. A device that could listen to the earth and authoritatively point to the troubled region was an unparalleled tool of political and spiritual authority. It demonstrated the emperor's connection to the cosmos and his ability to interpret its warnings. So, was Zhang Heng's dragon vessel a functional seismometer or a masterful ceremonial object? The most compelling answer is that it was likely both. It embodied a worldview where scientific observation and cosmic order were inseparable. The clang of the bronze ball was not just a mechanical signal, it was a voice from the earth itself, interpreted through human genius and channeled through a symbol of imperial grace. It reminds us that in the ancient world, the most advanced technology was often designed not just to measure nature, but to speak its language and assert humanity's place within a living, responsive cosmos. The dragon's bronze clang spoke of Earth's hidden movements, but across the world, another culture faced a different navigational darkness. Norse sagas whisper of a magical object, the solar stein or sunstone, a crystal that could reveal the hidden sun on overcast days or even during the twilight of the polar summer. For generations, this was dismissed as pure myth, a poetic metaphor for a navigator's intuition. But what if the skalds were recording a precise, if poorly understood, scientific practice? The key may lie in a transparent calcite crystal known as Iceland spar. When you hold a piece of this crystal and look through it, you see a double image. But more importantly, this crystal has a unique property. It polarizes light, filtering sunlight that has been scattered by the atmosphere and clouds. By rotating the stone and observing changes in brightness or the clarity of the double image, A skilled user could theoretically pinpoint the sun's position, even when it was completely obscured behind a veil of overcast. Modern experiments have proven this is not just theory, it works, so the debate shifts dramatically. It is no longer a question of if such a tool could exist, but how it was actually used on the treacherous, open waters of the North Atlantic. Was the sunstone a primary instrument, held up routinely by Viking navigators to chart their course alongside their knowledge of seabirds, whale migrations, and wave patterns? Or was it a tool of last resort, pulled from a sealskin pouch only when the sky had been uniformly gray for days and all other signs had failed, a secret weapon against disorientation and despair? This question cuts to the heart of how we view Viking society. The popular image is one of fierce raiders, yet their greatest achievement was not invasion, but exploration, settling lands from Greenland to potentially North America. Such voyages required not just courage but sophisticated wayfinding. The sunstone, if real and practical, transforms from a mythical gem into a symbol of this intellectual prowess. It represents a form of technology that bridged the observable world and the invisible forces of light itself. The mystery, then, is not locked in a tomb or buried in a field, but held in the hand of a sailor squinting at a cloudy sky, trying to discern a faint pattern of light within a crystal. It connects the tangible world of geology to the ethereal needs of navigation, reminding us that sometimes the most advanced science of an era is preserved not in a technical manual, but in the resonant lines of a saga, waiting for us to learn how to read its true meaning. A crystal revealing the hidden sun relies on the subtle physics of light, but another ancient image has sparked a far more literal and electrifying modern debate. Deep within the temple of Hathor at Dendera, Egypt, carved into a stone wall from the late Ptolemaic period, is a series of enigmatic reliefs. One in particular captures the imagination with startling clarity. It depicts a large, elongated object shaped almost like a modern light bulb or a giant elongated pear. Inside this bulb, a snake extends along its length, and the entire assembly is held aloft by a pillar with a figure standing nearby as if in attendance. To a contemporary eye conditioned by our own technology, the resemblance to an electric lamp is uncanny. The snake looks like a glowing filament, the bulb its protective glass, the pillar a sturdy stand, and the attendant figure an operator. This visual echo has fueled a persistent fringe theory, the idea that the ancient Egyptians possessed and used electric lighting, perhaps powered by primitive batteries like the disputed Baghdad jar, to illuminate their deep, windowless tombs and temples. This interpretation, however, collides directly with the overwhelming consensus of Egyptology. Scholars point to the rich, well-documented symbolic language of Egyptian religious art. In this context, the relief is not a technical diagram, but a profound cosmological scene. The bulb-like object is almost certainly a giant lotus flower, a plant of immense symbolic importance. In creation myths, the first god was said to have emerged from a primordial lotus that bloomed on the waters of chaos. The snake inside is not a filament, but a deity, often associated with the sun god emerging from the lotus at the moment of creation, representing rebirth and the dawn of light itself. The pillar is a jed pillar, a symbol of stability, and the entire tableau is a ritual enactment of divine emergence and eternal renewal, carved in a temple dedicated to a goddess of sky, music, and life. The scene is about metaphysical light, not practical illumination. The Dendera relief controversy is less about the artifact itself and more about our own perceptions. It serves as a perfect and vital cautionary tale. It demonstrates the powerful temptation to project our modern technological framework onto the past, to see our own reflections in the artifacts of a culture that thought in profoundly different terms. When we look at that carving and see only a light bulb, we risk missing the entire point. we silence the ancient voice that is trying to speak of gods emerging from flowers, of cosmic order rising from chaos, of light as a divine principle rather than a convenient utility. The lesson here is one of humility and context. Before we ask if an ancient object could be a piece of advanced technology, we must first and earnestly ask what it meant to the people who made it. We must seek understanding within their own cultural, religious, and artistic framework. Sometimes the most illuminating discoveries are not about finding our technology in their past, but about learning to see the world through their eyes, where a flower could hold a snake that was also a sun, and light was a story carved in stone, waiting not for a switch to be flipped, but for a myth to be remembered. A story carved in stone can be interpreted, but a story stamped in clay without a key is a different kind of silence. On the island of Crete, in the ruins of the ancient Minoan palace of Phaistos, archaeologists unearthed a flat, fired clay disc about 6 inches across. Its date is estimated at around 1,700 years before the Common Era. Both sides of this disc are covered, from the outer edge spiraling tightly into the center with a series of beautiful, precise symbols. There are human figures and animals, plants and tools, all created not by hand but by pressing pre-made stamps into the soft clay before it was baked. This is the Phaistos Disc, and its existence is a perfect, self-contained storm of mystery. The immediate and undeniable fact is that this is writing. The systematic, repeated use of stamped symbols arranged in a deliberate spiral is a form of recorded language. Yet from that one solid fact, every single other question fans out into a fog of uncertainty. The first, most fundamental debate is about its very nature. What kind of text is this spiraling script? The symbols, depicting shields and helmets, captive figures and ships, have led some to propose it records a military campaign or a legal treaty. Others see the prevalence of flora and beehive-like shapes and suggest it is an agricultural calendar or a ritual hymn to a nature deity. There is even a compelling, if less scholarly, theory that the disc is not a document at all, but an ancient board game, its spiral path a track for pieces, its symbols indicating spaces with different meanings. Each interpretation paints a radically different picture of the disc's purpose, and thus of the hands that held it. Was it held by a priest, a general, a scribe, or a player? This uncertainty is compounded by the disc's most haunting characteristic, its utter uniqueness. Not a single other example of this specific stamped script has ever been found anywhere in the Minoan world or beyond. In the study of ancient languages, decipherment relies on patterns, on finding the same words or phrases in multiple contexts, on having a bilingual text like the Rosetta Stone to provide a bridge. The Phaistos Disc offers no such footholds. It is a linguistic island, a message with no sender we can identify and no receiver we can question. This makes the debate over its function inseparable from the debate over its language. If we believe it is a prayer, we will try to read the symbols as divine names and pleas. If we think it is a royal decree, we will search for verbs of command and titles of authority. Our theory about its purpose dictates how we attempt to crack its code, and since the code remains unbroken, we are left circling the same unanswerable questions. The disc, therefore, becomes more than an artifact. It is a mirror. It reflects the limits of our modern analytical power when faced with a truly isolated creation. All our technology, our statistical analysis and computational linguistics stumbles against this single, silent object. It defies categorization because it belongs entirely to its own moment, a thought made physical, whose context has evaporated. The Phaistos Disc does not just ask us to translate its symbols, it asks us to consider the fragility of knowledge itself and how a civilization's most important message can become, to future eyes, nothing more than a beautiful, spiraling enigma. The silence of the Phaistos Disc is a language lost, but in the jungles of Central America, another civilization left behind objects that speak a visual language we can see, yet struggle to fully understand. From the sacred cenotes and royal tombs of the ancient Maya come some of the most breathtakingly intricate stone objects ever crafted, the so-called eccentric flints. These are not the simple, utilitarian blades one might expect. They are masterworks of lithic technology, chipped from brittle flint or gleaming obsidian into wildly complex shapes, sometimes stretching over 2 feet long. Their forms are a menagerie of myth and power, depicting the profiles of gods with elaborate headdresses, coiled serpents, skeletal figures, or utterly abstract, swirling designs that seem to defy the very nature of the stone itself. The first and most undeniable fact about these objects is their profound fragility. The slender, projecting elements and delicate notches mean that even a slight mishandling would snap them. This immediately eliminates any theory of practical use as weapons or tools. They were never meant to cut, to chop, or to hunt, so what was their purpose? The prevailing view for decades has been a purely ceremonial one. They are considered exquisite ritual offerings, destined from the moment of their creation for sacred caches or royal burials, meant to accompany and honor the gods or the departed in the afterlife. Their value lay in the immense skill required to make them and the spiritual potency of their forms, literal stone prayers offered to a cosmos the Maya saw as alive and interconnected. Yet a closer look at some of these complex shapes has sparked a more tantalizing line of inquiry. Could these ritual objects also have been instruments of knowledge? Some researchers, examining the precise angles cut into certain eccentrics, the strategic placement of notches, or the alignment of protruding points, propose they might have functioned as specialized measuring or sighting devices. A particularly complex eccentric with multiple arms set at specific angles could, in theory, be used to track the passage of the sun across certain temple doorways or to calibrate sightings of Venus, a planet of supreme importance to Maya astronomy. The notches might mark key dates within their intricate calendar system. This theory suggests the objects are dual in nature, sacred offerings that also physically embodied and perhaps even actively used celestial knowledge. The debate, then, is not simply about function but about how we categorize ancient thought. To insist they are only art is to potentially overlook a layer of applied science. To insist they are primarily tools is to risk undervaluing their spiritual essence. The most compelling resolution lies in the Maya world view itself, where such a distinction would have been meaningless. For the Maya, astronomy was not a detached science, it was the divine machinery of time, directly governing the fates of kings and the cycles of agriculture. A priest astronomer using an eccentric flint to mark a solstice was performing a simultaneously scientific and sacred act. The object itself was a conduit, its shape a prayer in geometry, its alignment a conversation with the gods. The eccentric flint, in all its fragile beauty, ultimately challenges our modern compartments. It suggests that in some ancient minds, the most advanced technology was not separate from devotion, but its highest expression, a brittle, beautiful bridge between the earthly and the celestial, crafted not for the marketplace but for the stars. The intricate stone prayers of the Maya measured the divine clockwork of the cosmos, but in the bustling heart of ancient Athens, time itself was governed by a more fluid and audible master. The steady, relentless drip of water marked the passage of moments in the Greek clepsydra. We know these water clocks served a fundamental purpose in legal settings, where they limited the length of speeches to ensure fairness, a practical and democratic use of a simple principle. Yet fragments of text and archaeology hint that some versions, particularly the grand public clepsydra in the Athenian agora, were far more than just courtroom timers. Their potential complexity opens a debate not about what they were, but how deeply they choreographed the rhythm of an entire city. The core challenge is one of absence. While we have ceramic vessel fragments and outflow pipes, the complete mechanical assemblies of the most advanced clocks have not survived. This forces historians to become detectives, piecing together possibilities from scattered descriptions in plays, philosophical texts, and legal commentaries. The central question is one of scale and synchronization. Could these public water clocks have been engineered to provide a city-wide time signal? Imagine a central reservoir, carefully calibrated and refilled daily, that controlled a visual or audible marker, perhaps a flag that descended, a statue that pointed, or even the sound of a trumpet at a specific water level. This would transform time from a private measurement into a shared civic experience, synchronizing the start of markets, assemblies, and religious ceremonies. An even more tantalizing layer involves the problem of seasonal hours. In the ancient world, an hour was not a fixed 60-minute block. Daylight was divided into 12 equal parts, meaning an hour in summer was longer than an hour in winter. A simple, constant drip clepsydra could not account for this, but literary hints suggest some later Greek or Hellenistic models may have incorporated ingenious compensating mechanisms. Could they have used a conical inflow vessel that altered the water pressure, or even a primitive gear train linked to an adjustable scale, to automatically display these shifting seasonal hours? This leap would move the clepsydra from a timer into the realm of a true computer, a machine that mathematically corrected for the Earth's orbit. Skeptics rightly point out that the evidence for such gears in Greek water clocks is circumstantial at best, resting on interpretations of poetic language. They argue that most public clepsydras were likely elegant but fundamentally simple, their primary function being symbolic, a manifestation of the city's order and rationality. Yet this symbolic function is itself profound. Whether a complex geared machine or a beautifully calibrated vase, the public clepsydra represented a revolutionary idea. That time belonged not just to the gods or the household, but to the polis, the citizen body. Its steady drip was the heartbeat of democracy, a shared rhythm against which arguments were heard, votes were cast, and communal life unfolded. The debate over its gears is really a debate about the precision of that heartbeat, and how far the Greeks went to build a tangible, flowing manifestation of order in their world. The steady drip of the clepsydra measured time by human design, but an ancient stone from a far older culture may have tapped into a force embedded in the earth itself. In the lush heartlands of what is now Mexico, the Olmec civilization, often called the mother culture of Mesoamerica, flourished over 3,000 years ago. At their great ceremonial center of San Lorenzo, archaeologists uncovered a curious artifact, a carefully polished bar made of a dark, iron-rich mineral called hematite. To the untrained eye, it might resemble a ceremonial scepter or a simple decorative piece, but when a researcher suspended it from a string, something remarkable happened. The bar slowly rotated and came to rest, aligning itself roughly along a north-south axis. This simple test revealed a profound possibility. The Olmec may have held in their hands a primitive magnetic compass. The immediate question is one of intent. Did the Olmec understand what they had discovered? Hematite is a naturally magnetic mineral, and the artifact's alignment is a straightforward physical property. The debate hinges on whether this property was recognized and deliberately harnessed, or if it was merely a happy coincidence of a stone shaped for other reasons. Skeptics argue the alignment could be fortuitous, and that the bar's true function was symbolic or ritualistic, perhaps a status object for a ruler or a tool used in bloodletting ceremonies. They point out the lack of any other clearly magnetic tools from the same period. A single artifact does not make a technological tradition, yet the proponents of the compass theory see a compelling logic in the Olmec's monumental achievements. San Lorenzo itself is a masterpiece of large-scale planning, with its colossal head sculptures, massive platforms, and precise alignments. the idea that its builders might have used a directional tool to orient their grand constructions is deeply appealing. A suspended hematite bar consistently pointing north would provide a reliable, fixed reference line under the open sky, invaluable for laying out the foundations of temples or plazas with celestial or symbolic precision. This would place the recognition and application of magnetism in the Americas centuries, perhaps even a millennium, before its first well-documented use in China during the Han Dynasty. This debate ultimately transcends a single stone. It prompts a broader, more fascinating question about human ingenuity. How many times, in how many different corners of the world, did people first notice the strange pull of a certain rock, the way it twisted against a thread to face a constant direction? The Olmec Compass, whether a deliberate tool or an unconscious marvel, suggests that the fundamental forces of our planet quietly whispered to ancient observers everywhere. It hints at the possibility of parallel discovery, of different civilizations stumbling upon the same natural truth and weaving it into the fabric of their own unique world, one through geomancy and city planning, another through navigation and philosophy. The true function of the hematite bar may remain uncertain, but its silent alignment points us toward a unifying idea that the human drive to decipher the hidden order of the world is itself a universal force. That silent magnetic pull of the earth offered a fixed direction, but the daily march of time demanded a more personal and portable solution. In the pockets and pouches of traveling Romans, one might have found a remarkable piece of personal technology, a folding bronze sundial. These intricate objects, no larger than a modern pocket watch when closed, have been discovered from the damp frontiers of Britain to the sun-drenched villas of North Africa. Their existence is not a mystery, but their place in Roman life is a puzzle of practicality versus prestige. When unfolded, the dial reveals a complex inner world, a miniature grid of lines and a raised gnomon, the part that casts the shadow. To tell the time, the user had to perform a delicate series of adjustments. First, the dial had to be oriented correctly to true north, likely using a simple magnetic compass or by sighting the sun at midday. Then, a crucial and problematic calibration was required. The adjustable gnomon had to be set to the correct angle for the user's current latitude. This was the portable sundial's inherent flaw. Its accuracy was entirely dependent on the knowledge and skill of its owner. A merchant traveling from Rome to Gaul would need to know or guess the correct latitude setting for his new location, a piece of geographic data not commonly held by the average citizen. This leads directly to the core debate: were these beautiful objects genuinely functional tools for a mobile empire, or were they something else entirely? The argument for practicality is strong. The Roman world ran on schedules, military watches, market hours, legal appointments. A portable timepiece, even one with a margin of error, would have been invaluable for a centurion coordinating patrols or a trader meeting a caravan. Some dials even include inscriptions listing major cities and their corresponding latitude settings, like a primitive built-in manual, suggesting a sincere intent for use. Yet the counterargument gleams in the bronze itself. Many of these sundials are masterpieces of miniature metalwork, decorated with fine engravings of gods, zodiac signs, or imperial portraits. Their craftsmanship speaks of expense and taste. For a wealthy patrician on a journey, pulling out an exquisite, gilded sundial to conspicuously check the hour might have been less about precision and more about displaying one's education, wealth, and connection to the sophisticated science of the day. It was an ancient smartphone, a device whose utility was intertwined with its status. The variation in quality across found examples fuels this ambiguity. A crudely cast, unadorned dial found at a remote fort likely served a blunt, practical purpose. A jewel-like version discovered in a luxurious villa burial probably served a different master. This conundrum asks us to reconsider a modern assumption that technology is purely about function. In the Roman world, the line between a precise instrument and a luxury good was beautifully, intentionally blurred. The portable sundial was both a tool for measuring the sun's passage and a tangible symbol that its owner moved through a world ordered by reason, commerce, and imperial time, a world small enough to fold into the palm of your hand. A sundial measured the sun's deliberate arc, but a small wooden object from an Egyptian tomb seems to defy the very air it was meant to rest on. Discovered in a burial at Saqqara and dating to around 200 years before the Common Era, this artifact is often called the Saqqara Bird. At first glance, it is a graceful, stylized model of a falcon, a bird deeply associated with the god Horus. Yet one feature stands out: a distinct vertical tail fin that looks less like a bird's tail and more like the stabilizer on the tail of a modern airplane. This single, anomalous detail has launched a theory that soars far beyond traditional archaeology. Could this simple wooden carving be a model of a glider, evidence that ancient Egyptian artisans understood the basic principles of aerodynamics and flight? The idea is undeniably captivating. Proponents point to the fin's shape, arguing it provides lateral stability, a feature a simple bird model does not need. They highlight the artifact's smooth, almost aerodynamic form. Most strikingly, some engineers who have built and tested scale replicas in wind tunnels report that with a small adjustment, like adding the horizontal stabilizer wings that are missing from the original, the design can indeed generate significant lift. The data seems to whisper of latent potential, of a shape that wants to fly. Mainstream archaeology, however, hears a very different story. The overwhelming consensus views the object through a far more grounded lens. It is most likely a child's toy, a ceremonial object, or perhaps a weather vane for a sacred bark, its fin designed to catch the wind and spin. In a culture rich with bird symbolism, from the protective falcon to the soul represented as a bird, a beautifully carved wooden bird requires no extraordinary explanation. The central debate, then, is not really about the object's physical properties, but about the nature of evidence and the powerful allure of anachronism. Does the wind tunnel test prove ancient knowledge, or does it merely demonstrate that a shape carved for symbolic or decorative reasons can, by happy accident, possess aerodynamic qualities? The craftsman who shaped this bird thousands of years ago was almost certainly not thinking about lift coefficients or airflow. He was likely thinking about form, ritual, and beauty. Yet the controversy itself is profoundly illuminating. It exemplifies how a modern technological framework can cast a dazzling, distorting light on the past, making us see a model aircraft where its creator saw a vessel for the soul or a simple plaything. The Saqqara Bird challenges us to a delicate balancing act. We must honor our sense of wonder and the intriguing what if, without letting it eclipse the cultural context that gives the artifact its true historical meaning. It asks us to listen carefully, to hear both the whisper of potential in a wind tunnel and the silent, symbolic language of the civilization that placed this wooden bird in a tomb, hoping it would carry something precious into the sky of the afterlife. A wooden bird hints at flight, but an empire of stone and sky built its memory from a far more humble material, string. Across the vast expanse of the Inca Empire, administrators and historians did not write on parchment or carve in stone, they tied knots. The quipu, a collection of colored cotton or camelid wool cords suspended from a main rope, is often described as a complex accounting tool, a three-dimensional spreadsheet for tracking vast stores of grain, numbers of llamas, or population counts. The basic logic is elegant and proven: the type of knot, its position on the cord, and the color of the string all conveyed specific numerical data. Yet a growing examination of the most intricate surviving quipus suggests this view may be only the first chapter of a much larger story. Some of these devices are astonishingly complex, with hundreds of chords in a riot of colors, incorporating subtle variations in ply and twist, arranged in patterns that seem to transcend simple inventory lists. This complexity fuels a profound and urgent debate. Could the Quipu have been a full writing system, capable of recording narratives, laws, poetry, or even maps of the sacred landscape? The central question is one of scope. Was this a binary-like code limited to numerical data and categorical labels, a mnemonic device that served as a prompt for trained specialists, the Quipu who held the oral tradition needed to unlock its full meaning? Or did the knots, colors, and structures themselves encode specific words, concepts, and stories independently, making the Quipu a true script written in fiber rather than ink? The tragedy is that we may never know for certain. During the Spanish conquest, countless Quipus were systematically destroyed as objects of idolatry or superstition, and the keepers of the oral tradition, the living keys to this code, were lost to the immense hardships of that era. What remains are fragments of a vast, burned library. We are left staring at these intricate, beautiful objects, understanding their basic mathematical grammar but deaf to their possible poetry. They represent a complete information technology built on a logic entirely alien to alphabetic writing, a tactile, spatial, and chromatic language for organizing a world. The Quipu is not merely a mystery of function, it is a silent testament to a different way of thinking, a reminder that knowledge can be woven, layered, and tied, holding the memory of a civilization in a cascade of colored chords. The knotted chords of the Inca held data in 3 dimensions, but the Greeks sought to measure the world with a single, precise line of sight. Enter the Dioptra, a deceptively simple instrument that stands at a crossroads between earth and sky. Picture a sturdy wooden or bronze stand supporting a long, narrow sighting tube, not unlike the spyglass of a later age but without the lenses. This tube could rotate smoothly on a calibrated circular scale, allowing a user to measure horizontal and vertical angles with remarkable care. Its terrestrial purpose is clear and well documented. For Greek and Roman engineers, the Dioptra was the indispensable tool of their trade, the precursor to the modern theodolite. It laid out the arrow-straight roads that stitched the empire together, ensured the precise gradients of aqueducts that brought water across miles, and established the flawless right angles of monumental architecture. It was, in essence, the instrument that built the ancient world's infrastructure, turning ambitious vision into exact, buildable reality. Yet writings by the ingenious Heron of Alexandria introduce a compelling twist. He describes how the Dioptra could be used not just to sight along the ground, but to point it upward, measuring the angular distances between stars and planets. This single suggestion opens a rift in its historical identity. Was the Dioptra also a legitimate astronomical instrument? The debate hinges not on possibility, but on precision. The device's accuracy was fundamentally limited by the naked eye and the craftsmanship of its graduated scale. For aligning a sewer tunnel or a fortress wall, a small margin of error was acceptable. But for mapping the heavens, where a fraction of a degree could represent a vast cosmic distance, that same margin might render the data meaningless. Could the slight wobble in its wooden pivot or the difficulty of holding a star steady in a narrow tube produce measurements reliable enough for serious science? Skeptics argue that dedicated astronomical tools like the armillary sphere were far better suited for celestial work. They see Heron's description as a testament to the Dioptra's versatility, a brilliant engineer demonstrating how a surveyor's tool could, in a pinch, be adapted for stargazing, perhaps for teaching or for rough estimations. Proponents, however, hear a different story. They suggest that the finest dioptri, crafted by master artisans for learned patrons, might have achieved a level of refinement we underestimate. In the steady hands of a patient observer on a clear Mediterranean night, it could have gathered valuable positional data, contributing to the star catalogues that would later define astronomy. This ambiguity is the Dioptra's true legacy. It refuses to be categorized neatly. It represents a moment in the history of science where the tools for measuring the human world and the cosmic realm were not yet fully divorced. The same device that ensured a soldier's road was straight could also, on a quiet evening, trace the wandering path of a planet. This forces us to abandon our modern, specialized mindset. For a thinker like Heron, there was no firm boundary between engineering and astronomy. Both were expressions of geometry applied to the universe, whether that universe was a city plan or a constellation. The Dioptra's silent tube thus asks us a subtle but profound question. When we look at an ancient instrument, are we seeing a specialized tool, or are we seeing the adaptable mind of its user, for whom the whole world, from the soil to the stars, was a single, magnificent problem in measurement? The Dioptra measured the world as it was, but Chinese legend describes a machine that defied perception itself. Ancient texts speak of the south-pointing chariot, an ornate vehicle said to carry a figure with an outstretched arm that perpetually indicated the southern direction, no matter how the chariot twisted and turned along its journey. The principle behind this marvel is not magic, but a stunningly early application of mechanical genius, a differential gear system. This system, using a complex arrangement of gears connected to the chariot's wheels, would automatically compensate for every turn, keeping the central figure's pointer locked to the south as if guided by an invisible hand. It is a concept of such sophistication that it feels centuries ahead of its time. This leads to the central, tantalizing question: was this a real, functional tool that rolled through the courtyards of Han Dynasty emperors, or was it a magnificent thought experiment, a clockwork parable built to demonstrate the heights of Chinese engineering philosophy? The written records are compelling. Several historical texts, including the Songshi, or History of the Song Dynasty, provide detailed descriptions of its construction and operation, crediting its invention to the legendary craftsman Ma Jun in the 3rd century. Later Chinese engineers are recorded as building and refining it over successive dynasties. Modern reconstructions based on these ancient descriptions prove the mechanism works flawlessly, a testament to the accuracy of the textual tradition. Yet, archaeology has offered a stubborn silence. No physical remnant of a Han Dynasty south-pointing chariot has ever been unearthed. Not a single gear, not a fragment of its lacquered frame, has been found in a tomb or an imperial workshop site. This absence fuels the debate between history and folklore. Skeptics suggest the chariot may have existed primarily as a ceremonial automaton, a dazzling spectacle for state processions designed to symbolize the emperor's unwavering moral compass and divine mandate to rule. Its purpose was not to navigate, but to inspire awe and embody cosmological order. Proponents, however, argue that the precise technical descriptions and the later, verified reconstructions point to a genuine, if incredibly rare, technological achievement. They propose it could have served as a practical, if extravagant, navigation aid for imperial expeditions or military campaigns in unfamiliar terrain, a mechanical guarantee against losing one's way. The truth likely lies in the space between these ideas. The south-pointing chariot straddles the line between fact and symbolic invention, a device whose very existence proclaimed that human ingenuity could capture and hold a fundamental truth of the cosmos' direction. It became a legend that inspired generations, not because it was hidden, but because it represented a peak of understanding. A mechanical idea so elegant that whether one was built or not, its design alone was a monument to a civilization's desire to master the principles of their world. Gold gleams with an authority that can silence centuries of doubt. In the royal tombs of ancient Mycenae, Heinrich Schliemann uncovered a breathtaking gold cup, its surface chased with intricate scenes of bulls and warriors. He immediately identified it as the legendary Cup of Nestor, the very drinking vessel described in Homer's Iliad, a tangible link to the age of heroes. For decades, its function was unquestioned, a magnificent ceremonial rite for toasting and libations. The true mystery, however, arrived not from the Bronze Age but from the 20th century. In the 1950s, a small, previously unnoticed inscription appeared on the cup, painstakingly etched in the ancient Linear B script. It seemed to spell out a name, a direct connection to the Homeric hero himself, the ultimate proof Schliemann had dreamed of. This was not a discovery, but a creation. The inscription was a modern forgery, expertly added to an authentic, priceless artifact. This act of deception transforms the cup from a simple archaeological wonder into a complex case study. The debate is no longer about its ancient use, but about the powerful human desires that can reshape history itself. Why would someone risk damaging a world-famous treasure to add a fraudulent detail? The answer lies in the immense cultural weight carried by Homer's epics. For generations, scholars had debated whether the Trojan War was myth or memory. An object like this cup, already visually resonant with Homer's description, became a magnet for the longing to prove the stories true. The forger, perhaps a skilled artisan or even someone within the museum world, likely believed they were not committing a crime but completing a story, giving the world the confirmation it so desperately wanted. They inserted a modern fantasy into an ancient frame, blurring the lines between discovery and desire. For archaeologists, this presented a profound ethical and technical puzzle. How does one disentangle the genuine artifact from the later, invasive narrative? The process requires a forensic patience, using microscopic analysis to compare the wear patterns of the original goldsmith's tool marks with the sharper, unweathered edges of the modern etching. It demands a deep understanding of Linear B itself, which was only deciphered in the 1950s, ironically around the same time the forgery appeared. The forger's knowledge of the script was good but not perfect, and subtle anachronisms in the grammatical form betrayed the inscription's true age. This episode forces a humbling realization. The greatest obstacles to understanding the past are not always the gaps in the record, but the stories we are so eager to fill them with. The Cup of Nestor, in its compromised state, teaches a crucial lesson about the archaeology of the present. It shows how our myths, our national pride, and our hunger for connection can lead us to literally rewrite history, leaving behind a new kind of mystery for future generations to solve, one made not of ancient silence, but of modern words falsely etched in gold. Gold can be forged, but bronze endures, preserving a system of time that refused to be conquered. Discovered in a field in eastern France, the Coligny Calendar is a shattered mosaic of a lost world. This fragmented bronze tablet, inscribed with the intricate script of the Gaulish language, is not a list of kings or a record of battles, but something far more intimate, a detailed 5-year lunisolar calendar. Its very existence is a quiet act of defiance, a sophisticated Celtic time reckoning system created under the shadow of Roman occupation. The calendar's complexity is immediately apparent, meticulously marking months, days, and intricate intercalary cycles designed to synchronize the moon's phases with the solar year. But this precision only deepens the central mystery. What was all this careful calculation truly for? The surface of the bronze holds a crucial clue. Certain days are explicitly marked with notations meaning good or bad. This simple annotation shifts the entire purpose of the object. It suggests the calendar was not merely a neutral tracker of seasons, but a guide to the spiritual quality of time itself, a divinatory map for navigating a world alive with omens. This sparks a fundamental debate among scholars. Was timekeeping here subservient to ritual, or was ritual organized by this precise timekeeping? One view sees the calendar primarily as a practical agricultural guide. By knowing the exact lunar month and its relation to the solar seasons, a community could determine the optimal times for planting, harvesting, and breeding livestock, with the good and bad days perhaps indicating optimal weather patterns or traditional knowledge about fruitful periods. Yet the prominence of the luck markings argues for a stronger ritual purpose. It may have served as an authoritative schedule for the powerful Druidic class, dictating the exact days for sacred festivals, sacrifices, and communal ceremonies, ensuring every ritual was performed at the most auspicious celestial moment. In this reading, the calendar is an astrological almanac, a tool for harmonizing human activity with the perceived will of the gods and the rhythm of the cosmos. The most compelling interpretation, however, is that it was all these things at once. For the Celtic worldview, these concepts were not separate. A good day for planting was also a day blessed by the gods, a time when the earthly and spiritual realms aligned for prosperity. The calendar resists our modern categories because it embodies a complete, integrated philosophy. Time was not an empty vessel to be filled, but a qualitative force, with each day carrying its own unique spiritual weight and practical potential. This shattered bronze tablet, then, is more than a calendar. It is a window into a sophisticated European mind that measured the heavens not just to track days, but to listen to their meaning, crafting a complex, beautiful system to live in harmony with a universe they believed was speaking to them all along. The Celtic calendar measured time as a spiritual force, but in the arid heart of ancient Persia, another civilization mastered the very air they breathed. Rising from the flat rooftops of desert cities like Yazd are elegant, towering structures of mud brick known as badgers or windcatchers. At first glance, they look like simple chimneys, but they are in fact brilliant architectural instruments for passive climate control, a form of science built into the home itself. Their operation is a lesson in elegant simplicity. A windcatcher is a tall, capped tower with openings facing the prevailing wind. As the wind enters, it is funneled down the shaft and into the living spaces below, creating a cooling breeze. But the true genius lies in its second function. On still, scorching days, the tower works in reverse. The sun heats the top of the structure, warming the air inside it. This hot air rises and escapes out the top, creating a suction that draws cooler air from subterranean rooms or adjacent courtyards up through the building, a natural ventilation system driven by convection. The effect could lower indoor temperatures by dozens of degrees, turning a desert dwelling into an oasis of comfort. This undeniable effectiveness sparks a subtle but profound debate about the nature of ancient innovation. Was the windcatcher's perfect form the result of centuries of intuitive trial and error, a craft tradition refined by generations of builders who simply knew what worked? Or does its optimized design imply a deeper, more formal understanding of the principles of fluid dynamics and thermodynamics, a science of air and pressure that was calculated, tested, and systematically applied? The evidence whispers of both. The sheer variety of windcatchers with different numbers of vents and orientations tailored to specific local wind patterns suggests a highly refined empirical knowledge. Builders learned through observation which shapes captured the breeze most efficiently and which materials like thick mud brick best moderated temperature. Yet the precision of the designs hints at something more. To consistently create a structure that harnesses both wind pressure and thermal buoyancy requires a sophisticated, if unwritten, grasp of how air moves and heat behaves. It represents an engineering philosophy where the building itself becomes a sensitive instrument, calibrated to its environment. This challenges our modern, narrow definition of a scientific tool. We often picture handheld devices of metal or wood, but the windcatcher argues that the most profound instruments could be entire rooms, entire homes, designed to interact with fundamental natural forces. It expands science from something you hold in your hand to something you live within, a daily, silent dialogue between human ingenuity and the elemental world. A building can be an instrument for the air, but the most profound alignment sometimes began with a single, humble piece of wood. In the dry sands of Egypt, archaeologists have found objects that seem almost too simple to be significant. A forked palm rib with a vertical slit cut into it, accompanied by a simple plumb line. This is the Merkhet, and its apparent simplicity masks a sophisticated purpose that remains elegantly contested. The traditional interpretation paints a vivid picture of practical necessity. Egyptologists have long described it as a star clock. In this role, a priest or timekeeper would use the forked stick as a sighting tool. By aligning the slit with a specific bright star, often one in the constellation we call the Great Bear or Ursa Major, and using the plumb line to ensure a true vertical, the observer could track the star's transit across the night sky. As the star drifted, its position relative to the Merkhet would mark the passage of the night hours, a crucial service for timing religious vigils or the night watches of the military. It was a handheld observatory, turning the vault of heaven into a giant, readable clock. Yet a compelling alternative theory shifts the Merkhet's gaze from marking time to founding space. Some scholars argue its primary, and perhaps original, function was not for hourly measurement, but for the sacred act of laying out a temple's foundation. Before a single stone was set, the precise orientation of a temple was a matter of cosmic importance. A structure dedicated to a god often needed to be aligned with a celestial body, perhaps the rising sun on a solstice, or, more challengingly, with the unmoving pole star around which the heavens seemed to rotate. Here, the Merkhet's simple genius would come into play. An architect could use the sighting slit to fix a perfect north-south meridian line by observing the circumpolar stars, and the plumb line would guarantee a true vertical axis. This ceremony, called the stretching of the cord, is depicted in tomb paintings and was a ritual of immense spiritual weight, linking the earthly house of a god directly to the eternal order of the cosmos. This debate between timekeeping and alignment is not merely academic. It reveals the very fabric of ancient Egyptian thought. To ask whether the Merkhet was a scientific instrument for telling time or a religious tool for temple alignment is to impose a modern division that simply did not exist. For the Egyptians, measuring the stars' movement was a sacred act because the stars were divine. Laying a temple's foundation according to those stars was a scientific act because it required precise, repeatable observation. The Merkhet did not have two separate functions. It had one unified purpose: to harmonize human activity and construction with the divine machinery of the universe. It was a bridge between the earth and the sky, operated by hands that saw no distinction between prayer and precision. In its weathered wood and simple cord, we see not a puzzle of function, but a clear statement that to understand the world was itself an act of reverence. The sacred alignment of a temple began with a single wooden site, but in the libraries of Babylon, the stars were captured in a far more permanent medium. Among the thousands of cuneiform tablets recovered from that ancient city, a particular group stands out. They are not epic poems or royal decrees, but meticulous lists cataloging the names of stars and constellations alongside numbers that seem to denote their positions in the night sky. This is the Mesopotamian Planisphere, and it presents a mystery not of a single object but of intent. What were these clay records truly for? Were they the dry, scientific logs of early astronomers, the charged omens of astrologer priests, or something in between? The cuneiform script gives us the data, but the human mind that organized it remains just out of reach. At first glance, the tablets look like raw observation. They systematically note the heliacal risings of stars, the moments when a star first becomes visible just before dawn after a period of being lost in the sun's glare. This was a fundamental celestial event for many ancient cultures, often tied to the agricultural calendar or religious festivals. The precision of these timings suggests a rigorous, long-term project of watching and recording, a scientific endeavor aimed at understanding predictable patterns. Some tablets go further, arranging stars into constellations we still recognize today, like Leo or Scorpio, and assigning them numerical values that may correspond to their path across the sky. This looks like the skeleton of a star map, an early attempt to create a mathematical model of the heavens. Yet to label these tablets as purely scientific is to overlook the world in which they were written. In Mesopotamia, the sky was not a neutral expanse of physics. It was the active script of the gods. Every celestial event, from the march of planets to the flash of a meteor, was a divine message concerning the fate of the king and the kingdom. The scholar priests who made these observations were likely the same individuals who produced omen texts, which explicitly stated that if a certain star behaved in a certain way, then a specific event on Earth would follow. This forces a profound question. When a priest noted the position of Jupiter, was he gathering data to refine its orbital cycle, or was he decoding a warning from the god Marduk about an impending military threat? The most compelling answer is that he was doing both simultaneously. The distinction we make between astronomy and astrology would have been meaningless to him. Accurate prediction was the goal, whether that prediction was for the next lunar eclipse or for the fortune of the harvest. The precision served the prophecy. The deepest debate, then, is not about the final product but about the silent process. We have the clay results, but we lack the living methodology. How exactly did they translate the observed arc of a star into those specific cuneiform numbers? Did they use simple sighting instruments, like a water clock to measure time and a horizon marker to gauge altitude? Or were their methods more abstract, relying on inherited mathematical schemes and periodic tables they had developed over centuries? The tablets themselves are the answer sheet, but the exam questions and the working notes are lost. This missing manual leaves us staring at the foundational data of Western astronomy, seeing both its birth as a quantitative science and its deep roots in a world where every light in the night sky was a word in a continuous, divine conversation. Standing in the heart of Delhi, a city layered with centuries of history, is a column of iron that refuses to yield to time. The Iron Pillar of Delhi, erected over 1,600 years ago during the Gupta Empire, rises over 23 feet tall and weighs more than 6 tons. Its surface, once polished to a fine sheen, still bears Sanskrit inscriptions praising the valor of a king named Chandra, likely the Gupta ruler Chandragupta II. As a monument, its purpose is clear, a testament to imperial power and devotion. But as an object of science, it whispers a secret that modern metallurgy has spent decades trying to unravel. How has this ancient iron structure remained virtually rust-free in the open air for more than 16 centuries? The answer is not magic, but a subtle alchemy locked within the metal itself. Scientific analysis reveals the pillar is made of wrought iron of exceptional purity, with a remarkably high phosphorus content and a surprisingly low amount of sulfur and manganese. This specific chemical recipe is the key to its longevity. The phosphorus, reacting with the iron and oxygen, forms a thin, protective film of iron-hydrogen phosphate hydrate on the surface. This film is stable and adherent, acting as an invisible shield that prevents the corrosive rust cycles that would consume ordinary iron. This fact is undisputed. The great debate begins when we ask how this recipe came to be. Was this a deliberate, repeatable formula, born from a sophisticated tradition of chemical knowledge? Or was it a happy accident, a one-time masterpiece resulting from the unique composition of local ores and the specific smelting techniques used at that time and place? Proponents of deliberate design point to the pillar's very existence as proof of intent. The craftsmen of the Gupta period were master metallurgists, producing the iconic Delhi iron itself in massive furnaces. They argue that such consistent, high-quality production could not have been blind luck. The selection of ores, the careful control of the forge's temperature and air flow, and the meticulous forging process all suggest a deep, empirical understanding of how different materials behaved. They may not have known the atomic theory behind phosphorus, but through generations of trial and observation, they could have learned that iron from certain mines, treated in a certain way, yielded a superior, longer-lasting metal. This pillar, then, would be the pinnacle of that applied knowledge, a material engineered for eternity. Skeptics, however, highlight a crucial point. No other contemporary iron artifacts from India display this same level of corrosion resistance. If this was a controlled, repeatable technology, why is the Delhi pillar seemingly unique? They propose that the high phosphorus content was an unintentional byproduct, a gift of the specific ore used from the mines of central India, combined with the unique charcoal-based smelting process that failed to remove the phosphorus as modern blast furnaces do. In this view, the pillar is a singular marvel, a perfect storm of geology and traditional technique that produced an accidental wonder. This debate transcends metallurgy, touching on how we perceive innovation itself. Does conscious science require a written theory, or can it live entirely in the practiced hands of a craft, in the silent language of heat, hammer, and ore? The pillar, in its silent endurance, suggests that ancient mastery often resided in that very space, where deep observation and skilled practice yielded results so advanced they appear miraculous to us. It challenges us to see science not only in scrolls and equations, but in the enduring patience of iron that has watched empires rise and fall, while it simply stood, protected by a shield its makers may have understood only through the wisdom of their craft. That silent, enduring iron stands in stark contrast to a legendary moment of sudden, noisy revelation. The cry of Eureka is perhaps the most famous exclamation in the history of science, a story we all know. Archimedes, tasked with determining if a king's new gold crown had been adulterated with silver, supposedly solved the puzzle while bathing. Noticing the water level rise as he entered the tub, he realized he could measure the crown's volume by submerging it, compare it to a pure gold block of equal weight, and thus detect any fraud due to their different densities. He was so excited by this insight, the story goes, that he ran naked through the streets of Syracuse shouting, "I have found it." It is a perfect tale of genius, connecting a mundane observation to a profound physical principle. But this beloved legend masks a deeper, more technical debate that cuts to the heart of historical accuracy. Could Archimedes have actually performed this test with the precision required to detect a small amount of silver mixed into a gold crown? The simple water displacement method, as charmingly told, might not have been sensitive enough. Silver and gold have different densities, but the difference is not enormous. To reliably measure the tiny variation in volume between a crown of pure gold and one secretly blended with silver would require an instrument of exquisite sensitivity. This is where the hydrostatic balance enters the historical imagination. Such a device, a balance scale used while an object is submerged in water, could theoretically provide the precise comparative measurements needed. By weighing the crown both in air and in water, and doing the same for a pure gold reference sample, the difference in buoyant force would reveal the truth with mathematical certainty. The principle is flawless, and it is described in Archimedes' own surviving writings on floating bodies. So the debate is not about the principle, but about the physical tool. Did a working, precision hydrostatic balance exist in the 3rd century before the Common Era? Could Hellenistic craftsmen produce a scale stable and sensitive enough to measure the minute differences in water displacement between two nearly identical weights? Some historians and engineers argue yes, pointing to the sophisticated gearwork of the Antikythera Mechanism and the known Greek mastery of lever-based instruments. They see Archimedes not as a cartoonish figure leaping from a bath, but as a meticulous experimenter, likely using a refined balance in a controlled setting to demonstrate his elegant principle. Others, however, hear the ring of allegory in the Eureka story. They suggest the bathing tale is a later, simplified parable invented to illustrate a brilliant intellectual leap for a popular audience. In this view, Archimedes' genius was in formulating the theory of buoyancy and specific gravity in the abstract. The story of the crown and the specific instrument used to test it may be a compelling myth built around that core discovery, a way to anchor a complex idea in a memorable human moment. This separation of man from myth is not about diminishing a great mind, but about understanding how ancient innovation was recorded and remembered. Legends grow around foundational ideas, simplifying the often messy, technical process of discovery into a flash of inspiration. The Eureka, a moment endures because it celebrates the power of observation and deduction. Whether Archimedes used a tub of water or a finely calibrated bronze balance, the underlying truth remains: a profound principle was grasped, one that would forever change our ability to interrogate the material world. The story challenges us to listen to our cherished tales of invention, to hear both the timeless truth they carry and the quiet, practical ingenuity that may have been the real foundation of genius. The cry of Eureka echoes with a solved puzzle, but on the most isolated inhabited island on Earth, a puzzle remains stubbornly silent. On the shores of Rapa Nui, known to the world as Easter Island, the monumental stone moai statues are not the only legacy of its people. Scattered in collections are a few dozen wooden tablets, their surfaces covered from left to right and then flipped upside down in alternating lines with intricate, fluid glyphs. This is Rongorongo, and it is the only known candidate for an indigenous writing system in all of Polynesia. Each glyph is a miniature work of art depicting stylized human forms, birds, fish, plants, and geometric shapes, all carved with a shark's tooth in a precise, rhythmic sequence. Yet this beautiful script is a locked library. The debate over its purpose is a haunting echo of the island's own story. Were these tablets sacred texts, recording the creation chants and prayers that connected the people to their gods and ancestors? Were they practical genealogical records, tracing the lineages of chiefs and navigators across generations in a society where status was everything? Or could they have held a more scientific purpose, encoding navigational lore, astronomical cycles, or agricultural calendars vital for survival on a remote island? The tragedy is that we lack the key to test any of these compelling theories. The knowledge of how to read Rongorongo was catastrophically lost in the 1860s, when Peruvian slave raids devastated the island's population, taking away many of the learned elders and priests. This cultural rupture was so profound that by the time outsiders took serious interest in the tablets, no one remained who could fully understand them. The function of the tablets is now inseparable from the story of their silencing. Like the Phaistos Disc, they represent a complete system of communication whose entire context has evaporated. But unlike the single disc from Crete, Rongorongo offers a fragile thread of hope, a few tantalizing clues. Some of the glyphs bear a striking resemblance to motifs found in the island's rock art, suggesting a shared symbolic language. The alternating direction of the writing, a method called reverse boustrophedon, implies a sophisticated and deliberate format. Most poignantly, early European visitors recorded that the islanders treated the tablets with deep reverence, chanting from them during important ceremonies. This hints that their primary role was likely liturgical, a physical embodiment of sacred knowledge. Yet even if they were religious texts, they almost certainly contained more, weaving together history, astronomy, and practical wisdom into a single narrative thread, as oral traditions often do. The Rongorongo tablets now sit in museums, their wood slowly aging, their glyphs holding stories of voyages, kings, and gods that we can see but cannot hear. They are a stark reminder that scientific and historical knowledge is not just stored in information, but in the living chains of people who carry it. When those chains are broken, what remains is not just an undeciphered script, but a silent echo of an entire world's way of thinking, a final, beautiful message sent across time whose meaning we are still struggling to reconstruct from the quiet shapes left behind. A wooden tablet holding silent stories speaks of a lost world, but an iron instrument of precise lines helped build an empire from the ground up. The Roman Groma presents itself as a tool of pure function, a cross-shaped sighting device mounted on a tall staff. Its purpose seems straightforward: to survey perfect right angles and straight lines across the landscape. Roman military engineers used it to lay out the grid of their legendary military camps, the castra, and to plot the arrow-straight roads and orderly city blocks that became the empire's physical backbone. It was the essential instrument of Roman rational order, turning chaotic wilderness into measurable, buildable space. Yet this very act of imposing order was never merely an engineering task, it was a sacred one. This is where the clear function of the Groma dissolves into a deeper mystery of meaning. Before the first foundation stone of a new city was laid, Roman tradition demanded a foundational ritual known as the sulcus primigenius. A priest using a bronze plow drawn by a white bull and cow would cut a deep furrow to mark the future city's sacred boundary, the pomerium. Where the plow needed to cross the path of a future gate, it was lifted so as not to profane the threshold. This ritual was the city's spiritual birth, and central to conducting this ceremony with perfect, auspicious alignment was the Groma. The surveyor priest would use it to ensure the ritual furrow was plowed in flawlessly straight lines and exact right angles, aligning the city's sacred heart with the cardinal directions of the cosmos. So, what was the Groma's true purpose? Was it first and foremost a practical tool for engineers, a piece of brilliant but secular geometry that later became wrapped in religious ceremony because of its importance? Or was its geometric precision, its ability to create order from chaos, considered a divine property from the very beginning, making it an instrument as much for the gods as for the legions? The debate hinges on how we view the Roman mind. One perspective sees the Groma as technology that enabled ritual. Its accuracy allowed the priests to execute the sulcus primigenius with a perfection worthy of the gods, ensuring the city's physical and spiritual foundations were unshakable. Here, function precedes symbolism. The other, more compelling view suggests that for the Romans, such a separation would have been nonsensical. To create a straight line oriented to the cosmos was in itself a religious act. The Groma did not just measure land, it measured and manifested a divine principle of order, of rectitude against the formless wild. Its cross shape may have even echoed the cosmic cross of the cardinal directions. In this light, the engineer and the priest were two faces of the same role, both using the Groma to harmonize human endeavor with the fundamental structure of the universe. The instrument thus becomes a powerful symbol of Roman civilization itself, a blend of ruthless practicality and profound spirituality. It reminds us that in the ancient world, the most advanced technology was often designed not just to change the landscape, but to consecrate it, to draw lines on the earth that were both a blueprint for an aqueduct and a prayer for cosmic favor. The lines of the Roman Groma carved sacred geometry into the earth, but in the court of Han Dynasty China, a different mind sought to build a model of the entire moving sky. Zhang Heng, the same genius behind the legendary seismoscope, is credited with an even more ambitious creation, a water-powered armillary sphere. Historical texts from the period sing its praises, describing a great bronze framework of nested rings representing celestial circles, all set into motion by the steady flow of water, turning like a clockwork cosmos. It promised not just to map the stars, but to animate them, to make the silent dance of the heavens visible within the palace walls. Yet this magnificent vision exists today only in words. No physical trace of Zhang Heng's grand sphere has ever been found, not a single bronze ring or water clock mechanism. This profound absence forces a difficult question upon historians. Are we reading the blueprint of a real, monumental public instrument, or are we witnessing the poetic amplification of a brilliant theoretical design? The descriptions themselves are tantalizing but elusive. They speak of the sphere demonstrating the motions of the sun, moon, and planets, and even of a celestial globe rotating inside it, showing the stars. To achieve this with water power would require an incredibly complex system of gears and hydraulics, a mechanical marvel on par with the Antikythera Mechanism, but on a potentially larger, more public scale. Some scholars believe this is exactly what Zhang Heng achieved. They argue that the Han court had the resources, the metallurgical skill, and the mathematical knowledge to attempt such a masterpiece. In this view, the sphere was a working planetarium, a tool for education and imperial spectacle, proving the dynasty's mastery over cosmic principles through engineering. It would have been a breathtaking sight, a river-driven universe turning in real time. A more cautious interpretation, however, listens to the silence of the archaeological record. These scholars suggest the texts may describe an ideal, a conceptual model that was perhaps built at a smaller, demonstrative scale to prove the principle. The core innovation might have been the mathematical theory and the design itself, realized in a device meant for a handful of court astronomers rather than the public square. The water clock mechanism could have been simpler, turning a single model rather than a complex array of independently moving rings. The legend of a fully automated heaven, then, grows from the seed of a brilliant prototype. This debate is about more than gears and bronze. It touches on how we remember genius across centuries. In the absence of physical proof, achievement can be magnified by admiration. Each retelling of Zhang Heng's story, each poetic description, adds a layer of wonder, transforming a groundbreaking instrument into a myth of automation. This does not diminish his brilliance, it simply asks us to separate the man from the mythos. Whether he built a towering hydraulic universe or a sophisticated tabletop model, his conceptual leap remains staggering. He envisioned the cosmos as a comprehensible machine, its rhythms predictable and reproducible through human ingenuity. His legacy, therefore, is dual. It is a historical mystery about a missing machine, and a timeless testament to the human desire to not just observe the heavens, but to hold their turning rhythm in our hands, to build a small, ticking echo of infinity. That grand, ticking model of the Chinese heavens was a spectacle of imperial power, but navigation across the open ocean demanded tools of a more humble and personal scale. In the ruins of a Norse convent on Greenland's Uunartoq Island, archaeologists found a small, broken wooden disc, roughly the size of a coaster. Its surface is carved with a series of notches and lines that radiate from a central point. To a modern eye, it looks like a simple, perhaps even decorative piece of craftwork. Yet this unassuming fragment has ignited a fierce debate about one of history's great practical mysteries. How did the Vikings traverse the vast, featureless North Atlantic with such consistent success? The leading theory is as elegant as it is compelling. Researchers propose this disc is a surviving piece of a bearing dial, a type of solar compass. The concept is beautifully straightforward. On the long days of the Arctic summer, when the sun barely dips below the horizon, telling direction by sunrise and sunset becomes impossible. But at local noon, when the sun is at its highest point, it lies due south. A navigator could use this disc by placing a central gnomon, a small vertical pin, into its hole. By tracking the moving shadow cast by the sun throughout the day and marking its shortest length, they could pinpoint true south. The carved notches, according to this theory, could represent specific bearings or even the declination of the sun at different times of the year, allowing a seasoned sailor to correct for seasonal drift and find their latitude. It is a tool of pure observational genius, turning the sun's arc into a reliable guide. But the disk's broken state and the simplicity of its markings invite healthy skepticism. With only a fragment to study, can we be sure of its original form or full function? Could these lines and notches have served a more mundane purpose, like a template for embroidery or a game board for a simple pastime in the convent? The absence of any similar, complete artifact from the Viking world makes definitive proof elusive. This ambiguity, however, is precisely what makes the Uunartoq Disc so profoundly symbolic. It represents the immense challenge of reconstructing the practical knowledge of a culture that left few technical manuals behind. Viking navigation was an oral and experiential tradition, a skill passed from master to apprentice on the deck of a longship, not written on parchment. Every scratch on this wooden fragment becomes a potential echo of that vast, unrecorded knowledge system, a system that combined hard-won observation of whales, birds, wave patterns, and the color of the sea with tools like this possible dial or the legendary sunstone. The disc does not need to be conclusively proven as a compass to teach us a vital lesson. It reminds us that some of humanity's greatest technological achievements were not always monumental or made of enduring metal. Sometimes they were carved into perishable wood, used until they were worn out or broken, and understood so completely by their users that no one thought to write down the instructions. The true function of the Uunartoq Disc may hover between tool and talisman, but its silent, notched surface asks us to listen for the whispers of a lost expertise, where reading the subtle language of light and shadow on a piece of wood could mean the difference between finding a new world and being lost forever in the gray expanse of the sea. That wooden disc from Greenland measured the visible sky, but in the heart of ancient Mesopotamia, priests sought answers in a far more intimate landscape. They peered not at the stars but into the warm, intricate architecture of a freshly sacrificed sheep's liver. This was hepatoscopy, a cornerstone of Babylonian divination, and its tools were not bronze or stone but clay models meticulously shaped and inscribed with a map of meaning. These models are not grotesque artifacts, they are maps of a worldview, and they present a profound challenge to our modern categories of knowledge. To dismiss them as mere superstition is to miss the rigorous, systematic mind that created them. The Babylonian diviner operated with a startlingly methodical approach. He would carefully examine the sacrificed liver, noting every anomaly, every unusual lobe, every distinctive mark or discoloration. He would then consult his clay model, which served as a standardized reference chart covered in cuneiform inscriptions. These inscriptions did not record random guesses. They were the accumulated results of generations of observation. They stated clear conditional correlations. If the gallbladder is elongated in this specific way, then the king's military campaign will face hardship. If a certain lobe is missing, then a flood may come. This was, in essence, a vast, living database. For centuries, priest scholars recorded the state of the liver alongside the events that followed in the kingdom, building a statistical corpus of what they believed were cause and effect relationships between the divine world, communicated through the organ, and the human world. This practice forces us into a difficult but fascinating debate. Were these priests proto-scientists operating within a flawed paradigm? From our modern vantage point, their core premise that gods communicated through sheep organs is not scientifically valid. Yet their methodology, observation, documentation, pattern recognition, and prediction based on accumulated data mirrors the fundamental steps of the scientific method. They were applying a form of rigorous, empirical analysis to a universe they believed was actively communicative and intentional. The alternative view holds that this was purely a religious ritual, a sacred performance designed to legitimize royal authority and divine the will of the gods, with any semblance of system serving only to cloak the ceremony in an aura of objective truth. The most compelling resolution lies in letting go of our need to separate the two. In the Mesopotamian mind, there was no boundary between science and belief. The universe was an integrated whole where divine messages were encoded in the natural world, whether in the liver of a sheep or the path of a planet. To read those messages correctly required the most disciplined observation possible. The clay liver model, then, is not an instrument of ignorance but of a different kind of knowing. It represents a civilization's monumental effort to find order and predictability in a seemingly chaotic world, to build a system of knowledge from the careful, repeated study of the details before them. It asks us to reconsider what science is, not just as a set of correct answers, but as a deeply human impulse to observe, record, and predict, an impulse that has taken many forms across the long journey of understanding our place in the cosmos. But to track the slow, majestic procession of the constellations required a different kind of timekeeper altogether. In the quiet of an ancient library or the courtyard of a wealthy patron, a most sophisticated water clock might have stood, one that did not merely drip but displayed the very night sky as it turned. Known as the Anaphoric Clock, this device took the principle of the clepsydra and married it to the cosmos. Its heart was a rotating bronze cylinder, etched with a precise map of the stars and constellations. As water steadily filled a hidden reservoir, it drove a mechanism that turned this cylinder, mimicking the nightly rotation of the heavens. A fixed wire or pointer stretched across the cylinder's face, representing the horizon, so as the star map turned, different constellations would rise above this line and set below it, just as they did in the real sky. It was a mechanical planetarium and a clock in one, a silent performance of celestial motion synchronized with the passage of the hours. Yet for all its brilliance, the Anaphoric Clock presents a puzzle of practicality. How common could such an intricate machine have been? The surviving descriptions, primarily from the Roman architect Vitruvius and references to earlier Greek models, make its complexity clear. It required not just a reliable water flow, but a precisely engraved cylinder that accurately reflected the changing night sky throughout the year, likely needing adjustment or replacement for different seasons. This was not an object one could buy at a marketplace. Its extreme sophistication places it in a rarefied category, alongside wonders like the Antikythera Mechanism. This leads to the central debate: were these clocks functional public timepieces, or were they something more philosophical? One view sees them as the ultimate luxury timekeepers for the elite. In the home of a learned scholar or a powerful statesman, an anaphoric clock would be a breathtaking conversation piece, demonstrating the owner's wealth, intellect, and connection to the cosmic order. Its function was to tell time, yes, but also to inspire awe and philosophical reflection, to make the abstract concept of celestial mechanics tangible within a private space. The alternative perspective pushes this idea further, suggesting these devices may have been built more to prove a theoretical point than for any widespread use. They represent the pinnacle of Greek theoretical horology, a demonstration that human ingenuity could, in fact, mechanically replicate the grandest motions of the universe. Building one was an intellectual and engineering triumph, a testament to what was possible, even if it was too delicate, too expensive, and too complex to ever become commonplace. In this light, the anaphoric clock was less a tool and more a statement, a physical argument about the harmony between mathematics, mechanics, and the cosmos. It asks us to consider where we draw the line between applied technology and theoretical masterpiece. Perhaps for its creators, that line did not exist. To successfully build a machine that mirrored the starry vault was the ultimate application of their knowledge, a celebration of human reason's power to comprehend and even mimic the logic of the heavens. Whether it accurately told the hour for a sleepless philosopher or simply turned in majestic silence, its true purpose was fulfilled in its very existence, a whispering, water-driven proof that the universe could be held, understood, and set in motion by human hands. These silent objects scattered across time and geography are not isolated curiosities. They form a constellation, and when we step back to see the patterns they create, a deeper story emerges about why their mysteries hold such power over us. The most common thread is a profound loss of context. For each Roman dodecahedron, we have dozens of examples but not a single written word. For every Babylonian liver model, we have the artifact but the living tradition of its readers is gone. This is the great silence that follows the collapse of empires, the fading of oral traditions, the simple forgetting of what was once everyday knowledge. We are left with the answer, the physical object, but the question it was designed to solve has evaporated. This absence forces us into a game of historical detective work, where every theory is a plausible story, but the original script is missing. This leads directly to a second, unifying theme, the seamless blending of what we now separate as science and spirituality. Our modern world often draws a firm line between a tool and a talisman, between an instrument for measurement and an object for ritual. Yet for the makers of the Nebra Sky Disk or the users of the Merkhet, that line did not exist. Calculating the solstice was a sacred act because the sun was a deity. Aligning a temple with a star was a precise engineering task because it connected the house of a god to the cosmic order. These objects challenge our categories, insisting that ancient innovation was often driven by a holistic desire to understand, to harmonize with, and sometimes to influence a universe they saw as alive and communicative. The instrument was both a calculator and a prayer, and this brings us to the final, perhaps most revealing thread, our own modern biases. When we look at the Dendera relief and see a light bulb, or at the Saqqara Bird and see a model aircraft, we are holding up a mirror to our own technological age. We are tempted to project our frameworks onto the past, to find our own reflections in the artifacts of cultures that thought in fundamentally different ways. This is not a failure, it is a natural human impulse, but it is a cautionary one. It reminds us that interpretation is always a dialogue between the past and the present. Our theories about these objects tell us as much about our own values, our own mysteries, and what we consider to be advanced or rational, as they do about the ancient mind. Ultimately, these 30 mysteries endure not because we lack the ingenuity to solve them, but because they represent something more vital than a single function. They are windows, each one is a fragile, frozen moment, a glimpse into how a specific culture at a specific time attempted to model the chaos of the world into something understandable, predictable, and meaningful. They show us the universal human drive to impose order, whether through the gears of a clockwork cosmos, the knots of an administrative record, or the alignment of a temple with the stars. The conversation is not over because our understanding of the past is never static. A new archaeological find, a fresh look at an inscription with advanced imaging, or a novel theoretical model can suddenly illuminate a shadowy corner, rewriting a chapter we thought was closed. This is what keeps history dynamically alive. It is not a dusty shelf of solved puzzles, but a living, breathing dialogue where the silent artifacts of our ancestors continue to ask us questions, pushing us to re-examine not only their world, but the very nature of progress, knowledge, and our own place in the long, unbroken chain of human curiosity. From the geared wonder of the Antikythera Mechanism to the silent knots of the Quipu, our journey through these 30 debated instruments reveals a profound truth. Ancient ingenuity was not a straight line of progress we can easily trace, but a vast, varied landscape of brilliant minds working with the materials and philosophies of their time. These artifacts are not failures of understanding, but persistent invitations. They ask us to keep exploring, to keep questioning, and most of all, to keep marveling at the creative spirit that sought to measure the stars, predict the Earth's tremors, and map the very passage of time itself. Each object, from the humble wooden Uunartoq Disc to the majestic concept of Zhang Heng's armillary sphere, connects us to a timeless human drive. It is the drive to make sense of the world, to find order in chaos, and to leave behind a tool, a model, a message that says we were here and we tried to understand. This conversation with the past is never truly finished. Every new discovery, every fresh perspective, can cast a different light on these silent witnesses. If this exploration has sparked your own curiosity, consider this an open invitation to delve deeper. The channel is dedicated to more journeys into the mysteries that shape our history. We would love to hear your voice in the comments below. Which of these enigmatic instruments captures your imagination the most, and what do you think its true story might be? Your perspective is the next piece of the puzzle, because the story of our past is always being rewritten, one question at a time.